Dear students, our next topic for this course on C programming will be the concept of arrays in C. So, to understand arrays, let us start with a small animation to understand the difference between arrays and ordinary variables in C. So, in C we have been using lots of variables. So whenever we have a variable, say x, the C compiler stores this variable in a particular memory location, right? So the variable x is stored in a memory location inside the computer, and the variable x can store only one value at a time, right? But there are some situations where we will require to use or store more than one values in the same variable. We need to suppose we need to store the marks of 100 students in a class. So it's not necessary to create 100 variables for storing the marks, right? Instead, we can work with arrays. We can declare a single variable name and then we can store 100 values inside that variable name. So this is basically the requirement of arrays. So here we can see if the same name x or the same variable name x is defined to be an array, then C will allocate certain memory locations with the array. So under the same name there will be several memory locations where the several values of the same variable can be stored. Okay, so for this array, say it's an array which stores 5 values. So the first value will be written as x0. x0 will represent the first value of the array variable. Then similarly x1 will be the second value, then x2 will be the third one, x3 will be the fourth one, and x4 will be the fifth value of the array variable, right? So in this way we can store several values inside one single variable name. So that type of structure is called a array in C language. So you will see the arrays are very useful in writing C programs. Okay. So let us see the formal definition of arrays. So yeah, this is what I just remarked. Ordinary variables can store only one value at any given time. So they can be used only to handle limited amounts of data. However, in many applications it becomes necessary to store more than one value at a time in a single variable. So for example, an application may require to store the marks obtained by 100 students, and so creating 100 variables is a hectic task, right? So we need a powerful data type that would facilitate efficient storing, accessing and manipulation of a large amount of data items. So for this purpose, the C language supports a derived data type, okay, known as array, that can be used for such applications. So an array is a collective name given to a group of similar quantities. So it should be noted that an array can store several values, but each of these values will have the same data type, either it is integer or float or character. So it is a fixed sized sequenced collection of elements of the same data type that share a common name. Okay, the name of the array will be common, and in its simplest form, an array can be used to represent a list of numbers or a list of names, etc. So since an array provides a convenient structure for representing data, it is classified as one of the data structures in C. So each member in the list is referred to by its position in the list, just as we have seen in the video that the first element is referred as x0, the second element is referred as x1, right? So suppose we use the array name m to represent the marks obtained by 20 students, then the marks of the first student will be represented as M0, right? That of the second as M1, and so on. So in C, indexing of array starts with 0, not with 1, it starts with 0. So the ability to use a single name to represent a collection of items and to refer to an item by specifying the item number enables us to develop concise and efficient programs. Okay, so there are several types of arrays that can be used in C. The first one is one-dimensional array, then we have two-dimensional array, and another one is multi-dimensional array. So a list of quantities, first let us consider one-dimensional array. So a list of quantities which can be given one variable name using only one subscript, and such a variable is called a one-dimensional array. So the rules for naming an array are the same as those of naming an identifier, right? So like any other variables, arrays must be declared before they are used in the program. So this is a very special rule of the C language, that you have to declare any variable before you are using it in the main program. Otherwise, the compiler will show you an error. So the general format of array declaration is, so it's similar to variable. First we need the type of the array, then we need the name of the array, and then followed with size. So how many values the array will store. Okay. So the type specifies the type of elements that will be contained in the array. Okay. So for example, the declaration int x20 declares x as an integer array of size, sorry, it will be 20, it's not 10, of size 20. Size 20, right? Similar to initialization of variable, an array can also be initialized using the following format. So type of the array, the name of the array, then the size, that is optional, and a list of elements separated by commas. Okay, and included within parentheses. Okay, so it will be included within parentheses. So here you will get one, sorry, not parentheses, it included within braces, second brackets. Okay, followed with semicolon. So it's like that. Right. For example, int a5 equal to 5, 6, 0, 1, 3. Okay, so this declares, this initializes the array whose name is a and size is 5. So the same thing can be written as this, int a, without mentioning the size. So the C compiler automatically understands, since there are 5 elements here, so it will understand that the size of this array is 5, right? So once we declare it this way, or initialize it this way, so a0 will be the first element, that is 5. Say a2 will be the third element, so a2 is 0. Okay, so that way we can initialize. So let us see some programs of writing arrays or working with arrays. So this is the program number 23. Initializing an array. So this is a very simple program. So we have written two arrays. Int a5 is 150 minus 9 6. B is the array 4 5 and 10. Okay, and I is a variable, that is the counter variable for a loop. So in order to display an array, we need to use for loop or while loop or do while loop, any loop you can use, but the for loop is very simple, and it works within only one line, so it's very simple to write. So we use for loop. So printf, the array a is, so we need to display the values of this array. So for I equal to 0, so since the indexing starts with 0, and the condition for exiting the loop is I less than 5, because there are 5 elements here, and since the indexing starts from 0, the highest index will be 4. 0, 1, 2, 3 and 4. So that is why it is I is strictly less than 5. I plus plus printf %d backslash t ai. So this backslash t is given to make space between two elements of the array. So printf, the array b is for I equal to 0. So b if you observe, I have not mentioned any size here. The size is kept blank, but the elements are given. So 4, 5, 10. So it's an array of size 3. So for I equal to 0, I less than 3, I plus plus printf %d \t bi. Okay, so let us see how this program runs. 23, yeah. So the array A is 150 minus 96 and the array B is 4 5 10. Okay, now see, suppose I enter something like this here, say I less than say 10 I plus plus. In this case what will happen, let us see. Okay, so we have compiled it and see the array, so it's not showing any error, but I have written the indices up to 10, right, up to 9. So the first 5 elements are initialized, and the other elements, they are given any garbage value by the compiler itself. So these are taken as some garbage value. So if the elements are not initialized, the program will not show you an error. Instead, it will just take some arbitrary values for the undeclared or uninitialized elements, right? So we should be careful about this. If you are writing an array of size 5, so please maintain that the indices should be less than 5. Okay, so that is the thing. Okay, if we do not give this \t here, what happens? You see, what is the necessity of this \t? See, the array A is 15096, so you cannot identify what are the elements of the array. So \t is used for this purpose. After the element 1, we should have some space so that we should understand that the next element is 5. Okay, that is the requirement for \t. Okay, so let us have a look at another program. Program to enter an array and display it. So suppose we are not initializing the array within the program. Instead, we are taking the input from the user. Okay, so how to write that program? So printf enter the size of the array. So maximum size is 10 because we have defined A to be an array of size 10. So scanf %d %n. Printf enter the elements. So for I equal to 0, I less than n, I plus plus. Scanf %d %ai. Okay, that is what you have to be careful about. We are inputting an array, so we have to enter it element wise. So scanf %d %ai. Printf, the array is for I equal to 0, I less than n, I plus plus. Printf %d ai. Okay, here we will not use ampersand because ampersand is used when we need the scanf statement. Okay, so here we just need to display it, so it's ai. Okay, so let us check how this program runs. Enter the size of the array. Say I enter something like 5. Enter the elements 1 0 4 5 6. Okay, so the array is 1 0 4 5 6. Okay, so that is how the program runs. Suppose I enter say 11. Enter the elements 1 2 3 or 4 5 6. Okay, so here see, here there is some problem. Why this has happened? Because I have entered the size as 11, but in the definition I had used that I had declared that the array A is of size 10, maximum size 10. So that is why this error is happening. Okay, so we need to be careful about this. So let us see another program. Say program 2. This program. So program to find the sum of two integer arrays. Okay, suppose I need to find out the sum of two integer arrays. Okay, so just like we find out the sum of matrices or say vectors, one dimensional matrices, row vectors, column vectors. Okay, so element wise sum, that is what I am saying. So int I, a 15, b 15. So a and b are arrays of size 15, maximum size 15. So we can use less than 15 also. So printf. So in the last program we had seen that there was a problem if we enter more than the declared size. So if you want to check that, you can use this do while statement here. If you want that the user should enter, so you should not enter anything other than 15, yeah, anything more than 15. So in that case we can use the do while statement to put a check here. Okay, so it will keep on repeating this statements as long as you enter something more than 15. Okay, so when you enter less than 15 it will pass. Okay, so printf enter the elements of a, so we take the elements of a as input. Printf enter the elements of b, so we take elements of b as input. Then we will display what is a, we will display what is b, and then we will find out the sum. Okay, so again we need the for loop. For I equal to 0, I less than n, I plus plus, just display ai plus bi. Okay, so that is the simple program. So let us see how it runs. Program number 25. Enter the size of the array, say 5. Enter the elements 0, 1, 2, 3 or 5. Enter the elements of b, so 2, 3, 4, 5, 6. Okay. So a was this array, that is 0, 1, 2, 3, 4, 5. Sorry, 0, 1, 2, 4, 5. B was 2, 3, 4, 5, 6. So you see the sum, element wise sum. 0 plus 2 is 2, 1 plus 3 is 4, 2 plus 4 is 6, 4 plus 5 is 9, 5 plus 6 is 11. Okay. So that's how it works. So another program, let us see. Program to find the sum of the elements of an array. Okay, so I want to find out the sum of all the elements of the array. So we need one array here and another variable sum which is initialized to 0. So printf enter the size of the array. We can write it this way. Printf enter the size of the array. Okay, scanf %d %n. Printf enter the elements of a. So for I equal to 0, I less than n, I plus plus. So within the same for loop we can take the input as well as we can calculate the sum, keep on calculating the sum, or you can use a different for loop, no problem. So it's better to do it within the same for loop. So printf a equal to, so a is this value, and printf the sum of the elements is %d comma sum, the calculated value of sum. Okay, so let us see how it works. Program 26. Enter the size of the array, say 6 is the size of the array, and I enter 1, 2, 3, 4, 5, 6. So the sum should be 6 into 7 by 2, that is 21. Okay, so you see the sum of the elements is 21. Okay, so it's correct. Right, so there are several other programs for arrays. We will do it. Sorting the elements of an array in ascending order, descending order, finding the largest element of an array, smallest element of an array. Okay, so in the next lecture itself we will write those programs. Thank you.